Back again, still with the polynomial functions here, and now we are going to look at a couple of special cases in the factoring, and I'm just going to go through these two examples because you may come up against these at some time in your math career. And so let's just look at factor by grouping. So factor by grouping is when you have generally four terms. And we did it in grade 11, so just refresher. So let's look at the first example here. So we have these four terms, 1, 2, 3, 4 terms. Now what you're trying to do is group them and then factor to try and get something that's the same. So let's just try putting a bracket there, group that one, there, and group that one. Okay, so if I look now at what's common here, I can see there's a 4 because it goes into that, and x squared. Bracket, now I just go that times that is 3x, and that into that goes minus 2. So it's not quite the same as this bracket, but pretty darn close. So if I take a negative 1 out, that changes this to 3x because negative times a positive is negative, and that changes that to negative 2 because a negative times a negative is positive 2. Now I do the happy dance because if we look at this bracket and this bracket, they are the same. So I put those down, and then this and this form the other bracket. Now in math, like you always want to check when you're factoring, can this or this go further? Well, I know that can't because 2 can't go into 3. But when I look at this guy, a little thing in my brain flashes, difference of squares. Okay, difference of squares. So I remember that as 2x, which I showed you earlier on in the seminar, plus 1 minus 1. And this just drops down, and there's the answer. Okay, and this is pretty much the same. So if you did that, hopefully you would get a very similar answer to what we just had there. Okay, now this is a tricky one because sometimes when you have to factor fully, which we did just in the last video, you can't do it because if you take plus and minus 1 or 2, because that's what I told you, the last number, the constant, you take all the factors of it. If you plug those into these x's, you're not going to get a 0 in this situation because we call it the rational zero theorem because it's going to be a rational. All your x-intercepts of this function aren't going to be whole numbers. They're going to be fractions. So I call this the PQ method. Okay, so first of all, this is the Q, the first guy, and this is the P. So you take your P and you take your Q's and you find all the list of factors. So, well, if P is 2 and this is 12, I started listing them, so plus or minus 1. Here it's 1, 2, 3. I could go plus or minus 4, plus or minus 6, plus or minus 12. So now, when I list all the P's and Q's, so P over Q, I have this 1 over 2, so I have 1/2 and negative 1/2. I have this 1 over 3, I have 1/3, negative 1/3, 1/4, negative 1/4, and so on. Okay, so you have a whole bunch of things now you have to try. So let's just give it a go. Let's try one of these guys. So I'm going to just try 1/2 and see if I get a 0. So let's go and do our factor fully. So we have 1/2 we have 12, negative 8, negative 3, and 2. So remember, this comes down, right? So we have 12. Half of 12 is 6. We add, so negative 2. Half of negative 2 is negative 1. We add. Half of negative 4 is negative 2. And we got a 0. So we did it. That is a factor. So now I take this and write it as a factor. So some people do x minus a half, and that's correct. I prefer 2x minus 1. Okay, so either way is fine. Now we have to take this guy, the 12x squared minus 2x minus 4. And can this factor? So, well, let's give it a go. Let's take out our GCF, because I know a 2 can go into all those. So 6x squared minus x minus 2. All right. So now take this guy and say, let's do decomposition. And minus 2 times that to get minus 12. I'm trying to get a 1, so I know it's a 3 and a 4. So let's put in a 3x, and let's put in a 4x. I'm trying to get a negative 1, so negative and positive. So let's group. All right, and let's see what we get. So we got a 3x. So that's 2x plus 1. So that's what I want. Minus 2 comes out, and we get a 2x plus 1. And there's the happy dance, because there's what I got. So I know that that comes as 1. These guys come as the other one. This 2 has nothing to do with the actual factoring to get the roots, but it has a meaning in the factor because we are factoring here. So make sure you keep that 2 there. It's important when we are factoring, not solving. And then this first thing we got is right there, so it's 2x minus 1. So there's the answer.